Alright, so this lesson is lesson 6 of factors and divisibility. So first it wants us to list the whole numbers that are factors of 12. To do that, we need to find the whole numbers that divide 12 with no remainder. So we're going to write down the factor pairs of 12. So first I'm going to write 12 and then my factor bar. Okay, so I already know that 12 can always be divided by 1 and itself, 1 and 12. Okay, it is an even number, so it can also be divided by 2, so 2 and 6, and then it can be divided by 3 and 4. And those are all the factor pairs. And you can write them in order, so it'll be 1, 2, 3, 4, 6, and then 12. Okay. With 51, you might think that there are only two factors of 51, 1 and 51. But we need to make sure that there's nothing else. Okay. And the way we do that is we can divide 51 by a couple different numbers. Now, it's not even, so I know that 2 is not a factor of 51. Okay, so I'm going to try 3. Okay, so 3 goes into 5 once, that's 3. Subtract 2, bring down the 1. 3 goes into 21 17 times. Okay, so I know that I have 1 and 51 as factors, and 3 and 17. Now 17 is a prime number, so I know that there are going to be no more factors of 51. Okay, this next one is finding the greatest common factor of 18 and 30. The greatest common factor is the biggest, largest factor of both 18 and 30. So first I want to list those. So here's 18 and 30. Okay. So if I list the factors, I have 1 and 18, 2 and 9, 3 and 6, and 30 I have 1 and 30, 2 and 15, 3 and 10, and then 5 and 6. So I'm going to circle the numbers that are common factors, which means that it's the same. So 1 is 2, 3, and 6 are all my common factors. So the greatest common factor is going to be the biggest number, which is 6. Alright, this next part is divisibility, and it's just to see what numbers can be divided by. Okay, and there's a chart here to help you out with that. So a number is divisible by 2 if the digit is even. Okay, 4 if the last two digits can be divided by 4. Okay, 8 if the last three digits can be divided by 8. 5 if the last digit is 0, 5. 10 if the last digit is 0. 3 is if the sum of the digits can be divided by 3. So that would be like 111. If I add 1 plus 1 plus 1, that's equal to 3. So if 3, the answer here, can be divided by 3, then so can it. So 11 can be divided by 3. Okay, 6 if the number can be divided by both 2 and 3. And then 9 if the sum of the digits, again, can be divided by 9. Okay. A number with 1 0 is divisible by 2, 2 zeros is by 2 and 4, and 3 zeros by 2, 4, and 8. So which whole numbers from 1 to 10 are divisors of 9,060? So it's asking, which of these numbers can I divide that by? And so I'm going to look. So we already know that it can be divided by 1 because everything is. My number up here, it has a 0 at the end of it, so I know it can be divided by 10 and 5. It's also an even number, so it can be divided by 2. Okay. Now we need to check if it can be divided by anything else. So we're going to do 3. So if I add up the digits in that number, so 9 plus 0 plus 6 plus 0, I end up with 15. So 15 can be divided by 3. So 3 is one of the divisors of that number. And if I add them up again at 15, it is not divisible by 9 because 15 is not divisible by 9. Okay. We want to check 6, and remember, if for a number to be divisible by 6, it has to be divisible by both 2 and 3, which it is. So it can be divided by 6. Okay. With 4, the last 2 digits can be divided by 4. So the last 2 digits of my number are 60. Okay. So we tried dividing 60 by 4. Okay. Goes into it once. 4, 2, 0. That's 5. So yes, so it can also be divided by 4. It cannot be divided by 7. Sometimes you just have to check to see if it can. And it cannot be divided by 8 because the last 3 digits, 60, is not divisible by 8. So your answer is 1, 2, 3, 4, 5, 6, and 10. And that's it for this lesson.